Hey guys, welcome to the midterm review. We have 50 problems that we're going to look at together, so let's get started. On number 1 and 2 really, we have fractions that we want to simplify. Okay, so let's simplify them. We have 25 is going to go into 100 and 125, so that's going to be 25 goes into 100 4 times, and 125 5 times, so that's your answer. Now, on number 2, it's a little less common, and you can use your calculator to help you with this. All right, I don't want a decimal, I want a reduced fraction. So if you need help with how to get your calculator to give that to you, reach out to me and we can get that set up. All right, but here, I can tell you that 41, it goes into both of these. So I'm going to divide each one by 41, and we're going to get 5 over 12 for my answer. All right, remember, on number 3, when you multiply fractions, two things. You multiply across the top and across the bottom, and then any whole number is understood to be over 1. So if you need to put the 1 there, that's fine. But then you can either reduce first and then multiply, or multiply and then reduce. I personally like to reduce first because it keeps my numbers small. So I'm going to reduce first. But you do what's comfortable for you. 8 goes into 8 one time, and 72 9 times. And then 9 times 5 is 45. 1 times 1 is 1. We don't have to write that over 1. So that's my answer. On number 4, we're going to convert both fractions into improper fractions instead of mixed numbers because they're just easier to work with. Honestly, mixed numbers, unless you're dealing with recipes, aren't super helpful, and you rarely see them in the wild. Again, unless you're dealing with recipes and trying to cook and stuff like that. All right, but 5 times 2 plus 2, that's going to be 12 over 5 times 3 plus 1 is 10, so it's 10 over 3. Again, we're going to reduce where we can. 5 goes into 5 one time, 5 goes into 10 twice, 3 goes into 3 one time, 3 goes into 12 4 times. So that's going to be 8. All right, moving on. Number 5, 2 over 13 times 19 over 8. All right, so some of you may be familiar with the concept of KFC or keep, flip, change. All right, you keep your first fraction, you flip your second fraction, and then you change your division to multiplication. So that's what we're doing here. And then 2 goes into 2 one time, 8 goes into 8 4 times. Okay, and then 19 and 13 can't be reduced, so that's going to be 19 over 52. 13 times 4 is 52. And I remember that coupling because when it comes to playing cards, there are 4 suits, 13 cards in each suit, 52 cards in all. If you can take random math facts like that and attach them to something tangible, whether it's playing cards, whether it's time, whether it's money, this stuff starts to stick a little better, and you can pick it out of a crowd, pick it out of a lineup a lot faster. All right, switching gears. 6, we're dealing with adding and subtracting fractions. When you add and subtract fractions, the most important thing is to have common denominators. If you do, great. Put it in your answer and then work with the numerators. If it's not, you have to work to get common denominators, and then you have to work to get a single fraction. And you don't want to reduce too early, unlike multiplication where you could do it at the beginning or at the end. When it comes to adding and subtracting, if you don't have common denominators, you have to work to get common denominators, which, if you're not paying attention, some students start reducing too early, but then you're undoing the work that you're trying to do to get common denominators. So be careful with that. You want to work to get common denominators and then get a single fraction and then reduce as necessary. Here, 7 minus 6 is 1, so it's just simply going to be 1 over 21. That's my answer. On 7, we got to work a little harder. So typically when numbers are this close together, the smallest number that they're both going to go into is the product of the two. So in this case, 7 times 12 is 84. Okay, so both of these are going to go into 84, and I need to adjust the numerators accordingly. So 7 goes in 84 12 times. So that's going to be 12 times 1 is 12. 12 goes in 84 7 times. 7 times 1 is 7. Okay, and then you have 12 minus 7 is 5. 5 over 84. That's my answer. Again, you know that's not going to reduce because 5 only goes into numbers that end in 5 and 0. So just heads up on that one. Number 8, we don't have to change the mixed numbers to improper fractions. That would be a little too much work. But I am going to keep the big numbers and change the fractions to have common denominators. That's going to be plus 19. 4 and 5 go into 20. Okay, so both of these are over 20. 5 goes into 20 4 times. 4 times 2 is 8. 4 goes into 25 times. 5 times 1 is 5. Okay, so that's going to be something over 13, 20, and 16 and 19 is 35. So 35 and 13/20 is my answer. On number 9, we're simply going to take negative 30 and plug it into our formula that they give us. So F equals 9/5 times negative 30 plus 32. Okay, 5 goes into 30 6 times. 6 times 9 is 56. Oh, sorry, 54. So and it's going to be negative 54 plus 32. All right, and then that's going to be negative 22 degrees Fahrenheit. Okay, Number 11, the formula gives the heart rate in beats per minute of a person who is 8 years old. Found the heart rate of a person who's 30 years old. So I'm going to take 30, plug it into A, so that's going to be H, 3/5, 215 minus 30, 3/5 times 185. And then it says round to the nearest whole person, so if you get a decimal, you want to follow that rule. But I think this is going to be 111 evenly. It's going to divide evenly here. So that's going to be 111 beats per minute. Number 11, we have to combine like terms. So we got y here and there. We have a constant term here and there. So let's add them up. 7 minus 3 is going to be 4y. 2 plus 4 is 6. And that's how you combine like terms. It obviously can get a little bit more complicated than that, but that's the basics. And we only had 4 terms here. As you get more and more terms, it's even more critical, in my opinion, to mark up where are your like terms. Like here, I said y and y, and then my constant terms. All right, I recommend doing that as it gets more complicated and more terms continue to be added. Okay, here I'm going to distribute. So I'm going to take the 8 and give it to everything inside. I'm going to take the 3, give it to everything inside. All right, so essentially I'm expanding everything, and then I'm going to combine like terms. So 8 times 6 is 48, and the a is going to just hang out. 8 times 5 is 40, and the b is just going to hang out. 3 times 3 is 9, and the a is going to hang out. 3 times 5 is 15, and the b is just going to hang out. Again, you got an a here and here, a b here and here. So 48 plus 9 is 57a, plus 40 and 15 is going to be 55b. That's my answer. Now, on 13, you see problems like this, and it says the product of 5 and a number. Well, this is two things. One, this is you're taking the English and writing it in algebraic terms. All right, the product of 5 and a number could be any number. We don't know what number it is, but it's just a variable, and it can be any letter of the alphabet that you choose. We often choose X, but that doesn't mean you have to choose X. So 5 times a number, that's what it looks like, which is then added to a product of 13 and 9. So I'm going to add 13 times a number, same number, so 5x plus 13x. Now, sometimes it tells you to go ahead and find the number. Here it didn't, but we're going to do it anyway, right? Because if you set something up like this and you have like terms, it makes no sense to leave it like that. Just go ahead and combine. So this is going to be 18x. All right. Once again, we're going to take that 4. I'm going to distribute through. So 4 times 2x is 8x. 4 times negative 6 is negative 24. Right. And then everything else is just going to come down. All right. Again, you got like terms. 1. Okay. 8 minus 4 is 4x. Negative 24 plus 10, that's going to be minus 14. And that's that. Moving right along. All right, scores in golf can be positive or negative integers. For example, a score of 7 over par can be represented with plus 7. A score of 4 under par can be represented as minus 7. If Donna has a score of 5 over par, 6 under par, and 8 under par, for 3 games of golf, what is her total? So this is what we got. I got 5 minus 6 minus 8. So I'm going to add this up, and that's going to be 5 minus 14, and that's going to be negative 9, which in this problem means 9 under par. So a lot of times when it comes to application problems, getting the answer is just part of it. Then you have to interpret what you just did. In this case, it's not enough to just say, I got negative 9. That's what the algebra says, but what is the problem asking you for? It's asking you for her score, and in golf, it's over par, under par, or par. So in this case, 9 under par is what we're looking for. All right, on 16, half is 14 and half is 7 in my denominator. I need 14s all across my denominator, so let's make that adjustment. So I got 14 here, 7 goes in 14 twice, so 3 times 2 is 6, minus 5 over 14, plus, all right, I already know this is going to be 6 over 14, because it's the same fraction, minus 3 over 14. Okay, 6 minus 5 is 1, plus 6 is 7. All right, if that's too much for you, you can do this in parts. So if I do the first two, let's do it this way. If I do the first two, that's going to be 1 over 14, and then this is going to be 3 over 14, and I'm adding, this is going to be 4 over 14, and that I can reduce. This is going to be 2 over 7. So whatever way you want to do it, you could do it all at once, 6 minus 5 plus 6 minus 3, or you can chunk it like I just did. 17, we have 3 minus 5. 3 minus 5 is negative 2. Negative 3 minus 7, all right, that would be minus 10y. Okay, when my signs are the same, you add and keep the sign. So both of my y terms, they're both negative, which means they're both signs are the same. So I add and keep the sign. So 3 plus 7 is 10. They're both negative, so I make my answer negative. Okay, easy peasy. All right, on 18, this is very similar to one we did earlier, but we're going to take if you need to, you can put this over 1, but then we're going to reduce. We got negative 9, 9, and technically I can get rid of that negative as well, because 2 negatives make a positive. So all I'm left with is 4. Okay, and to be clear, this is 1, and 1. So 4 was the only thing left. All right. Ooh, forgot the y. So don't forget the y. So this is what's left. 4y is what's left. Okay, 8 times 7y is 56y, plus that's going to be 16, minus, and when we have parentheses separated with a minus like this, we want to make sure that that negative gets distributed to everything in the second parentheses or whatever's behind it. So this is going to be minus 32y and minus 24. All right, once again, 56 minus 32, that's going to be 24y, and then 16 minus 24 is going to be minus 8. Okay, there's that. All right, number 20, the cost in dollars of having a car towed is given by the algebraic expression 3x plus 40, where x is the number of miles the car is towed. Find the cost of having a car towed 2 miles. Okay, well, I'm just going to plug 2 into the equations. This is going to be 3 times 2 plus 40. That's going to be 6 plus 40, which is 46. All right, and that's going to be dollars. So it'll cost me $46 to have it towed 2 miles. All right, starting with 21, we deal with exponents. So this is the same thing as saying 11 times 11 times 11. All right, so don't get tripped up over that. And for this one, this is going to be 1331. Here, this is the same thing as saying negative times 10 times 10 times 10. Notice I didn't include the negative in my parentheses, and that's because there's no parentheses to begin with. Had the parentheses been wrapped like that, then I would have included it. Regardless, it's not going to change my answer. It's still going to be negative, because whether it's inside the parentheses or outside the parentheses, in this situation, I have an odd number of them, and so my answer will stay negative, and it's going to be negative 1,000. Okay. Here, same thing, but this time it's the same thing as negative 6 times 6 times 6. So you may not know what 6 to the 4th is, but you can use your calculator for help. So that's going to be 1296, and remember, it's negative. Now, had this been inside of parentheses here, that would have been a positive 1296, but parentheses is everything. The power is only attached to the thing next to it. Sometimes that's parentheses, and sometimes it's not. If it's not, you can't expand what it's attached to. It just doesn't work that way. And a lot of students, when they start to struggle with order of operations, they start to make up their own rules, and that's where you get in trouble. So starting with 24 and 25, we're really focused on the order of operations here. So on 24, let's do this a little bit at a time. All right, when it comes to order of operations, it's please excuse my dear Aunt Sally, or parentheses, exponents, multiply, divide, add, subtract. I have to do parentheses first, or any kind of grouping symbol, like absolute value, brackets, braces, parentheses, and the like. All right, and then you can do exponents. So, and then you have multiply, divide. You can do multiplication and division in any order after you've done parentheses and exponents and before you add and subtract. And then you can add and subtract in any order once everything else is done. Typically, you can do it left to right, but you don't have to stick to that. It's just kind of, if you don't know where to start, go left to right. That's kind of the thing. Sometimes if you're working without a calculator or something like that, maybe you jump around depending on the terms and keeping your numbers small, or things you're working with, things you're familiar with, stuff like that. When you're working with fractions, order of operations looks a little different, because I want to, if there's not overarching parentheses or grouping symbol, then I want to work strictly with the numerator, strictly with the denominator, and then only once everything is done in each one, then I look at both as a whole. So here, I got 48. 9 minus 6 is 3, minus 12. So I did the parentheses in the top, and now I'm going to do the exponent at the bottom. So this is going to be 9 minus 3. 48 times 3 minus 12, that's going to be 132 over 6, and that's going to be 22. Okay, same thing on 25. You get 3 plus 4 on the front, so that's going to be 7. And then you got 5. 7 plus 3 on the inside, so that's going to be 5 plus 10. 7 times 15, which is 105. On 26, anytime you're dealing with a fraction like this, what I like to do is simply multiply everything. You have to deal with the 6 in the denominator, and you have to deal with the 5 in the numerator. You can do it separately or in 2 steps, or you can do it all at once. And to do it all at once is my preference, and that just means you're going to multiply by the reciprocal. Okay, That allows everything over here to go away. And then I have 5 goes into 5 one time, 5 goes into 15 3 times, and then my answer is going to be 3 times 6, which is 18. 27. I'm going to subtract 20 from both sides. So that's going to be 6x equals, that's going to be negative 3. X equals negative 3 over 6. And you can't leave a fraction like that. So this, I reduce it, and that's going to be negative 1/2. 28. I'm going to add 11 to both sides. That's going to be negative 5x equals negative 35. I'm dividing by negative, so x equals positive 7. Positive 7. Okay. Now, when you're on the same side, I'm just combining like terms. So negative 7x plus 4x, that's going to be negative 3x plus 2. I do this first. You want to clean up your sides before you work across the equal sign. All right, so this is going to be negative 3x plus 2 equals negative 8x. I'm going to add 3 to the other side. Let me show that. Plus 3x plus 3x. Okay, that's going to be 2 equals negative 5x. And then when I divide by negative 5, x is going to be 2 over 5. And let me show you this. All right, the negative can be out front, it can be up top, it can be in the bottom. It's really your preference. You don't need more than one negative, obviously. All right, but you can decide, is it going to be up top, is it going to be in the bottom, is it going to be out front? But the answer is going to be negative 2/5. And you read it the same way regardless of where that negative is living. Number 30. If 30 is divided by a number, so 30 divided by x, didn't have to be x, but we're going to use x, the result is 5, so equals 5. All right, and once again, it doesn't tell me to find the number, but I can clearly work this. So let's work it. X is in the bottom. I can't have it in the bottom. I'm going to multiply everything by x to get it out of there. So that's going to be, multiply everything by x, so that's going to be 30 equals 5x. And now to get x by itself, I'm just going to divide by 5, so that's going to be 6. Okay. 31, it says the formula C equals 532x plus 155 models, plus 155 models the data for the cost to produce X units of a product, where C is given in dollars. How many units can be produced for a cost of $425,000, 755? Okay, well, it tells you it's asking for units, so we're looking for X. I'm going to plug in 425, 755 equals 532, X plus 155, and I'm looking for X, so I got to move this around. So it's going to be minus 155. Okay, so that's going to be 425 minus 600 equals 532. You divide both sides by that, and X is going to be 800. So how many units? 800 units. 32. Again, you want to clean everything up on both sides before you work across the equal sign. So you got 4x and 4x, it's going to be 8x minus 8. 3x and negative 9x, it's going to be minus 6 plus 20. I'm going to add 6 to both sides, or 6x. And that's going to be 14x minus 8 equals 20. I'm going to subtract or add 8 to both sides. So it's going to be 14x equals 28. So x equals 2. X equals 2. Okay, number 33, I'm going to distribute. So that's going to be 12t minus 4 times 18 is 72. Minus 4 equals 44. 44. That's going to be 12t minus 76. I'm going to add 76 to both sides. 12t equals 120. T equals 10. Okay, number 34. All right, we're going to multiply everything out and then clean it up. So that's going to be 6x plus 6. Don't forget to distribute to that back end. Sometimes you can move a little too fast and forget to multiply all the way through. All right, so it's going to be 2 and 6 is going to be 8x. 5 and 6 is 11. Negative 7x minus 7. I'm going to add 7x to both sides. It's going to be 15x plus 11 minus 7. Subtract 11 from both sides. It's going to be 15x equals negative 18. 15x equals negative 18. And so x equals negative 18 over 5, or 15. And I have to reduce that, so it's going to be negative 6 over 5. 3 goes into both of those. You get negative 6 over 5. All right, so on 35 and 36, I can get rid of the fractions altogether. All right, this is called fraction busting. It looks like 3, 5, and 15 all go into 15, so let me multiply by 15 to every term. So this is going to be 3 goes in 15 5 times. 5 times 4 is 20. 5 goes into 15 3 times. 3 times x is 3x. 15 goes into 15 one time, so the answer is 1 here. I'm going to subtract 20, so that's going to be 3x equals negative 19. X equals negative 19 over 3. Okay. Now, 36, same thing. Looks like everything goes into 6, so I'm going to multiply everything by 6, and that's going to be 6 goes into 6 one time, so I'm just left with my numerator here. 3 goes into 6 twice, so I got 2 times the numerator here. 6 goes into 6 one time. 1 times 7 is 7. Okay, let's multiply this out. 2x minus 2, 7. 3x plus 4 equals 7. 3x. It's going to be 3. So x equals 1. Okay, 37, we could also multiply to get rid of our decimal, but this one is so simple, it doesn't really make sense to do that. So let me subtract this on both sides. So that'd be 15.4 equals 7.7, and so x equals 2. Number 38. You're going to work both sides, so you got 3x plus 9 equals 3x plus 9. Now, if both sides are the same, then when I start to move stuff, everything's going to start to fall out. I don't have to move much. Let me move the 3x, and you're going to find, so let me say minus 3x, minus 3x. You're going to find that both of those are going to fall out, which means I'm left with 9 equals 9. And then when you're left with this, you have to ask yourself, is this true? Does 9 equal 9? In this case, yes, it does. In some cases, it doesn't. Not 9 equals 9, but like you're going to end up with something that is a false statement. This is a true statement, so it works. Okay, so if it works, like it does here, that means no matter what I plug into this thing, whatever I plug in for x, it's going to work. So this would be all real numbers. Contrary, if I end up with a false statement, then no matter what I plugged in, nothing would work, and that would be no solution. This one is all real numbers. Okay, let's see, 2x plus 10 equals 2x minus 20. Okay, again, I'm going to subtract 2x. All right, and you'll find these fall out. I'm left with 10 equals negative 20. All right, this is an example of a false statement. 10 does not equal negative 20, and so this is no solution. And you can spell it out, or you can say 0 with the line through it. Okay, 3 times 5 is 15. 15x plus 3 minus 21 equals 11x minus 2. I'm going to clean this up. That's going to be 15x minus 18 equals 11x minus 2. Subtract the 11x, that's going to be 4x. It's negative 2. Add 18, that's going to be 4x equals 16. X equals 4. Okay. Last page. 10 more problems to go. 41. If 3 times a number is added, so 3 times a number, it doesn't have to be x, but we're going to use x. 3 times a number x is added to negative 9, so plus negative 9. The result is equal to 12 times the number, so 12 times x. And in this case, it says actually find the number. So we don't have a choice here. So this is going to be 3x. Remember that adding a negative is the same thing as subtraction, so I'll clean that up. I'm going to subtract 3x from both sides. So that's going to be negative 9 equals 9x. So x equals negative 1. Okay, all right, starting with 42, we're dealing with inequalities. All right, so we're going to work with these to get x by itself. And we want, unlike equal signs where it doesn't really matter where x is on, like on the previous problem, x was on the right, and in our previous other problems, it was on the left, x equals a number or a number equals x. That's not a best practice when it comes to inequalities. In inequalities, the best practice is to write everything from left to right. So x needs to be on the left, your number needs to be on the right. Okay, so in this case, I'm going to subtract 9x from both sides. Okay, that's going to give me x plus 2 less than or equal to 8. I'll subtract that, and it's going to be x is less than or equal to 6. So what does that look like? Well, if I draw the line, you have 6. And this is one of the reasons why best practice is to write the inequality from left to right. X is less than or equal to 6. All right, it tells you which direction you're going to shade. And because it's equal to, less than or equal to, it's a bracket, and I'm shading to the left. Okay, if it was just less than without the equal to, it would be a parentheses. And then my interval for this would be negative infinity to 6. Parentheses on infinity, bracket on 6. 6 is included. Infinity is something we never get to. It's a concept, so we're always approaching it. Okay, I'm going to multiply everything, or excuse me, I'm going to divide everything by negative 2. And because I multiply or divided by negative, I'm going to flip this. And that's going to be negative 1 over 14. There's no equal to here. So this is going to be parentheses, shade to the right. Okay, and that would be negative 114, parentheses, comma, infinity. And that's it. 44. I would multiply everything by the reciprocal. So 3 over 2. That gets rid of these. And then I don't have to multiply by the parentheses. This will be 2x minus 1 less than. 2 goes into 6 3 times. 3 times 3 is 9. It's going to be negative. There's that. I'm going to add 1 that says 2x less than negative 8. X less than negative 4. So x is less than negative 4. And negative 4. Again, tells you where it's shading. So less than, it's going to be parentheses, shade. Okay. 45. When I subtract x, you'll notice that they fall out. And now it's asking 9 is greater than or equal to negative 2. Right? That's true. 9 is greater than or equal to negative 2. And again, because the x fell out, this is always true. Okay, so this is all real numbers, but we write that differently when we're talking about interval notation. So this is going to be negative infinity to infinity, negative infinity to positive infinity. 46. 10x plus 12 greater than 10x plus 100. Again, I'm going to subtract 10x. That's going to leave me with 12 is greater than 100. This is not true. This is not true, so this would be no solution. 12 is not greater than 100. All right, 47. Claire has received scores of 85, 88, 87, and 90 on her algebra test. What is the minimum score she must receive on her 5th test to have an overall score of at least 87? Okay, so first of all, we're going to take the average of 85, 88, 87, 90, and some 5th test that we don't know yet, over 5. She can have an 87, and she can have more than an 87. She just can't have less than. So it's going to be greater than or equal to 87. Okay, so when I solve this, two things. The top numbers, 85, 88, 87, and 90, are going to add up to 350 plus x. And then when I multiply by 5, it's going to be 435. I'll subtract 350 from both sides, and I'll find that x is greater than or equal to 85. So as long as Claire makes an 85 or higher, she's great. She'll keep an average of 87 or higher. All right, on 48, you see the negative 4 and the 6 in parentheses and the semicolon. If you see something like this, this is asking you to plug it in. This is an ordered pair. Plug in the ordered pair, see if it actually works. All ordered pairs are written xy. So you got 6 is equal to negative 4 plus 10. And then you're seeing if one side equals the other. That's how you check to see if it's a solution. So 6 equals negative 4 plus 10. Negative 4 plus 10 is 6. So this works. So that means, yes, it is a solution. 49. Here is slightly different. It's similar, but it's I don't have an x and a y, I just have an x. So I'm plugging this in, I'm just going to figure out what it's going to give me. All right, so that's going to be 25 plus 8, which is 33. All right, so that's what y is, and then I write my answer xy, so this is going to be 5 comma 33, and that's my solution to this. Okay, now, graphing. Right, this is written in y equals mx plus b form, where m is rise over run, and is my slope, and b is my y-intercept, or my starting point. Here, we have 1. Positive 1 is going to be my starting point. That's where I'm at right there. And then it says my slope is 3. Again, rise over run. And any whole number is understood to be over 1. So rise 3, run 1. So 1, 2, 3, over 1. There's my 2 points. I only need 2 points to draw a line. You can draw multiple, but you only need 2 to draw the line. And so let's connect the dots. That looks good. Show that it goes on forever in both directions. And then that's it. That's your review. All right. Best of luck on the midterm. And if you have any questions, please reach out. See you later.